shell and start installing it and start doing some random things to MongoDB to see how it works. So the important thing to notice is that MongoDB has three major dimensions as a product. It's a general purpose, meaning that we want to be able to use MongoDB or make sure that MongoDB is fitted to work on any sort of use case. It's a document-oriented database, meaning that we store information into documents. And most importantly, it's also open source. So there's no spooky software going on running and dealing with our data. It's all out there. It's all open source. You guys can use it, abuse it, make cool stuff out of it. We welcome contributions, all the good stuff about open source projects. In terms of data, so the way we typically understand data is through relational systems. So we have tables. Those tables will have foreign keys and joins, and we will relate compartmentalized sets of information like a big spreadsheet that we can then relate data from one place to another. Now MongoDB takes a completely different approach from that. For us, what we look into is what is data meaning for your application. So how does it fit your application needs? How do you conceive it in this class or in a set of attributes? How you define a piece of information. So the example that we have here is a user that will have a few attributes like what his name is, where he lives, the geo-coordinates, and how many cars he has, and so sort of that kind of information. If we had the relational system, we will have, for example, a person and then its cars table, and then some way we will relate all that information. In MongoDB, we just store all of it together. Now, there's a lot of benefits to using a document model. It gives us a lot of agility and flexibility. It's more intuitive and natural to work with that data representation because it reflects directly what your application is doing instead of just spreading all your information into different tables. It also obviously reduces the need for joins and seeks, and this is a computational benefit in terms of speed. Not only how you find and fetch information, but also how you update it, how you write it. There's a lot of dynamics going on there that makes it a much more scalable system as well, because if data is all together in one single document, you can take that data and just move it across different servers, and you have a more scalable system. You will not need to move portions of tables, for example, all around from server to server. Now, the idea behind MongoDB is to make developers, more and more often, or more and more these days, to make also system administrators more successful and more capable of working with the system. But for developers, the idea is that you should concentrate in your application and then let MongoDB offer you things like text search, geospatial capabilities, aggregation capabilities, MapReduce if you want to, even rich queries. The idea is to make you guys much more productive if you're on the developer side. If you're on the administration side, we also want you guys to have all the sets of features and functionality that you're already using. So we are doing more and more integration with things like Chef, like Puppet, making sure it works well with SNMP's protocols, make sure they have your alerting system and monitoring system, all of that working very well together. And the other good thing about MongoDB is it tries to bring together the two different worlds that we have these days in terms of database choices. From one side, we're going to have all the very rich expressive query language that we can use any kind of field on any kind of attribute with lots of different operators to find our data. We're going to have a strong consistency model, meaning that we don't have this half-baked, data can be there or cannot be there depending on which node you're talking to and how you write it and all that stuff. You always write to the single machine. You can read it from several if you want to, and we can scale that system. And obviously, we're going to have secondary indexes, which are extremely important if you want to optimize your queries. We don't always look for our primary key. We also do secondary indexes searches, and we need to build those in an optimized fashion. On the other hand, the NoSQL world gives us a lot of flexibility. So every time we want to change the way that our data is represented, we don't want to do a migration or an alter table because those are expensive. We also want to be able to scale, and this is extremely important, making sure that if you're becoming successful, if your application now has 1,000 users, but tomorrow will have 1 million, you want to make sure you keep on growing, and the database is not going to be a pain. And obviously, performance. This is one of the major reasons why people move to a NoSQL solution, is because either their speed of ingestion of data is not good enough, or their speed of reading data is also dragging them into scaling up or making wrong choices due to the fact that their database cannot speed up their processes. So building this together is the MongoDB architecture definition, so to speak. Now, a database has to have a couple of components. First of all, it needs to be highly available. One system that if the primary node goes down and you have to manually boot it up in the middle of the night in your pajamas back at home, that's not cool, and we don't need that. MongoDB offers you high availability, automated failover. It makes sure that if for some reason shit happens, so it will happen, a node fails, you will have secondary nodes that will keep up with the service, so you don't need to actually worry about it. The system will take care of that. It has a synchronous replication mechanism that allows us to make sure that everything is up to date, and also gives us, from a pure administration perspective, a lot of good, flexible, let's say, ways of making sure that the system is maintained. If you want to replace a machine, you can just, with confidence, take it down, the primary, let the secondaries take over. If you want to do upgrades to our software and so on, we will not be jeopardizing the service that we are providing just because we have to do a maintenance operation. Obviously, replica sets, it's the definition that we use to these groups of high availability nodes. We're going to have a primary. That primary is going to have its data replicated to secondaries, and we address the common concerns like high availability, the disaster recovery, and the maintenance. There's a bunch of different benefits from a business perspective, from a technical perspective. I'll make sure, I'm not going to go and read all of this because that will be boring. I'll make sure that all the slides are going to be available so you guys can have a mismatch here between what MongoDB does in terms of a replica set and what probably your business will need or your application technically will require. There's also flexible storage architecture. And for this, it's important to understand how we conceive the product in terms of, let's say, the different layers that MongoDB implements. If you consider the top of the diagram as different use cases, like here you have IoT sensor, content repo, ad service, real times, mobile application, whatever application you have, we offer that application or the drivers that you're implementing your application on a MongoDB query language, which is basically a set of operators that you have and a set of functions that you can call to manage your data. Internally, MongoDB will have a data model, and this is a document data model. This is a BSON structure where we are going to organize all of our data. This MongoDB data model will be also responsible for making sure that we can scale out, making sure that we have replication in place, making sure that we have all these mechanisms that you don't need to worry about. And below that, we offer different storage engines. Now, this is important because each one of those use cases on top might have completely different requirements in terms of read-write ratios or availability of service or just purely the performance required to respond to their SLAs. An ad service, it just wants to push data as fast as it can to closest as possible to their users. A IoT sensor probably is much more focused on ingesting a lot of information per second and then running long batch reports on it. Or real-time analytics, you probably want to have all that speed of reading, also that speed of writing, because you're going to have to deal with real-time requests. So all of these might have a different need in terms of storage capacity. And this is what MongoDB also offered. So we have our WireTiger, is our default storage engine. Then we also have our legacy one called mmapd1. And we also have a set of different variations, like an in-memory storage engine, an encrypted storage engine, and you can even plug in your own if you want to. So if you are kick-ass C++ developer and you know all about databases and you know that you can do way better than we do, you can plug it in, and MongoDB, as long as you implement our API, you can use it to store your information on the low level. On the sides, we're going to always maintain with your application with management protocols and integrations, like making sure that you have a plugin for your monitoring systems through SNMP, or we're going to have a set of applications that allow you to manage and maintain a good look of what MongoDB is working with. And also, obviously, security, which is an important aspect. If we're dealing with data, we want to make sure that that data is secure. Right, so how do I get started to learn MongoDB? Coming to this presentation is a good way to start, so kudos to you guys. The second one, and probably the most revealing and more important one, is to sign up to one of our university courses. So we have a big bunch of them. I'm actually the lead engineer in that content, so if you guys sign up for the courses, they're all online, they're all free. So that's the best way to start learning MongoDB and start having a good feel of what MongoDB can do for you. We have courses for developers, for administrators, advanced courses, beginner courses, all sorts of different offer there that could entertain you for months if you want to. Right now, what we are going to do today is basically install MongoDB on a VM, bring up a service, do our first shell connection, perform some CRUD operations, and review some administration commands. And obviously, as you all know, live demos is like spinning plates on some arrows. Things can go bad, so let's hope it doesn't. Now, let me see if I can move this correctly. So I'm just going to get out of this system. Let me know if you guys lose visibility of what I'm doing. Can you still see my shell, my vagrant box?
I sure do.
All right. In the meantime, I'm biting my pizza. Sorry for that.
Rub it in, why don't you?
So what I have here is a data set already uncompressed in this folder. Oh, actually I didn't, so I'm going to do that. So I'm going to call term. I'm going to extract the file, dataset tgz. Sorry, incorrect location. There we go. Extract the file, dataset. All right, so this file is not working. That's okay. That's the first glitch that we have in our demo. What I'm going to do is actually bring up MongoDB not as a service right now, just as a single process. So the first thing that we need to do is basically call it. I'm going to specify a DB path. By default, we will set it up on DB. I don't have that folder created, so I'm just going to use this data folder that I have here on this on my home folder. Okay. I can specify a port where I'm going to be listening to incoming connections. By default, it's 27017. And I can also fork the process to the background. But for that, I would need to deliver, I'm going to log the system's logging into a file. Let's call it mdb.log. Okay. Right now, I'm not going to do that just yet because I want to show you guys how the bootup actually works. So once I do this, the first thing that we can see is obviously what version of MongoDB am I running. Here I'm running the version Enterprise, so it's going to have OpenSSL compiled into. You can see the version exactly that I'm using and a bunch of other stuff. Now, this is a development version in MongoDB, 3.3.12. The way we number our versions is that we're going to have major, values for the release. Sorry, this is the epic value for the release. This is the major number of the release, and this is the minor version. Every time you see an odd number on the major value of the release, this is going to be a developer version. So this is the version that we're working on for the upcoming official release. Every time you see an even value, sorry, this is even or odd? I'm a foreigner, so I don't even know. This is even, right?
No, that is odd.
That's odd. Okay. All right, so I'm doing good. So every time you see an even, like 3.2 or 3.0 or 2.8 or 2.6 or 2.4, that will be a production version. So that will be okay to put in a production environment. But since we are now playing around with it and I have this version installed, we are all good. We can just use it. Now, the only other thing that we also going to have is basically a diagnostics data. This is something that we just added by default, which will capture a lot of diagnostics as we go along. So if you run into a problem and if you want to debug any sort of issue that you might have with MongoDB, you'll have a folder where we are capturing a bunch of information about MongoDB execution itself. All right, so I have another option here, which is to just jump into our vagrant box from another shell. I'm just going to put it a little bit bigger so we can all see. So this is my vagrant box. I connect to it through vagrant SSH. And once I'm getting into that same box, I'm just going to connect to that running instance. So let me just readjust here the windows. Let me know if you guys are back at home are good and you can see what's going on.
Yeah, now, I can see.
MongoDB is the daemon. It's our server that I just booted up. Okay, it allows us to do a bunch of stuff, set up a ever-growing set of parameters. It allows us to do a lot of stuff. To connect, our default way would be to use a shell. And in MongoDB world, it's Mongo. We are very, very good at naming our products. So once we connect, we can see that on the logs of our server, we got a connection accepted. Fantastic. We can see that we are receiving metadata from this fella, and the application it is connecting is our Mongo shell. Fantastic. Everything is logged. We can see everything. And obviously, this is women in Linux group, so obviously I could only use some version of Linux for this demonstration. All right, so what we have here is our Mongo shell enterprise version. And the first commands that we can type is something like show DBs. Okay. By default, MongoDB comes with two databases. One is admin and another is local. Admin is just basically a namespace that we use for administration purposes. It doesn't necessarily hold any data, although it does, but you can't see it to manipulate it. It's just basically a namespace that we can use, a placeholder, so we can express certain commands, certain administration commands. And then we have local, which basically holds some local instance information. Considering that we have a replica set and we can set up this in a distributed fashion, we might have different needs for local instances. This is where we're going to go and basically store all that information. Now, the other thing that we can do is show collections. Now, if you are coming from MySQL world or any other relational system, you probably would expect us to call things tables. And actually, that command still works. But in MongoDB nomenclature, this is actually a collection. This is a collection of information inside a given namespace. So now I'm going to just move into a different database, which I'm going to call Women on Linux or Women Linux. And I'm going to start inserting data. I'm going to call my DB handler. And on that, I can name a collection, say, like, for example, people. and I can insert. Obviously, might have a user, and that user might be Tamika, and on purpose, I'm spelling it wrong, and she has a title, I guess, which is the leader of this group.
Yeah.
Okay, so once I have this is the definition of a document. It's a JSON structure that MongoDB will ingest, and we can store that particular information into that collection called people. Once we get it in, we get a response back saying, okay, your result has been successfully inserted. And this is the number of inserts that we processed. Obviously, if we can insert, we can also update. Let's say, for example, that in this case, I have made a mistake spelling Tamika's name, and I want to go into my system where the user is Tamika and actually change it, or better say, setting it to a different thing. Is this correct, Tamika? Is this better?
That's much better.
That's much better, right? So once I do this, I'm actually operating on the document and just setting this value, this field, to the proper value. Once I do that, it's going to tell me that for some reason I'm doing something wrong, which is basically not saving this correctly. Let me see what is wrong here. Oh yeah, so I'm missing to close here a string. There we go. Boom, we got it. So we matched one document and we've been able to update it. We also can do selects. So let's say that we have people and we want to find. When I express this, this will be a command that looks for documents inside a particular collection. And as you can see here, I have all the information correctly set up. Now, we have not used this underscore ID field for anything. We didn't set it up when we initially inserted. Now, MongoDB allows you to do any sort of object, any sort of data structure. It's completely flexible. It doesn't check for anything unless you tell it to check. But the only requirement that it has for each document is that it needs a primary key. And we define it by default as underscore ID. And if you do not say anything as primary key or as the value of underscore ID, it will set this object ID field. Now, this object ID field is basically a timestamp plus MAC address plus PID plus a counter binary value. You can actually even, if I do find one and ask for the underscore ID, for example, in JavaScript nomenclature, I can get the value, and I can get, for example, the timestamp. Let's see if this works. Oops. Or let me just put it into a variable, let's say ID, and I now can do, whoops, I cannot call getter objects. Well, it's, you can get the timestamp. Get timestamp. Right? Let's see if this works. There we go. So from the values themselves, you can extract some information. Now, I can only do this way because this is actually a JavaScript interpreter. The Mongo shell is nothing less than a JavaScript interpreter that I can express queries like the following. Can iterate over 10 elements, and I can say that people collection will have, and I can insert a bunch of different documents where I equals I, for example, or number equals I. Now, if I do this, this is actually nothing to do with the previous documents. The previous document has this structure. It has a user, has a title, it has an underscore ID, and the one that I'm inserting in the same collection, actually it's pretty different. So will this be able to be inserted? In a regular database, you probably couldn't. Here, we actually do it. Now, the right result that we are getting is only from the last operation. If we query our people collection, you will see that we have all the 0 to 9 values. Okay? Now, how is this possible that we have such a diverse and distinct set of different documents inside the same collection? In relational systems, this is not possible. The only way to do it would be to just have a blob field or something like that and just throw into that blob field whatever type of information we want. In MongoDB, that doesn't really matter. For us, what we want to know is what kind of data you want to store. If it makes sense to you to organize it all under the same collection, then we just do it. That's as simple as that, as it can get. Obviously, this is also prone to error, because if someone messes up, we can, get into trouble. But it's also very flexible in the sense that we can filter based on the types of documents that we have. Let's say, for example, that I only want to find documents that the user value or the user field exists. It will be as simple as saying, okay, find me please all the documents that at least have user. Once we do that, we filter only the ones that we really want. We can also do the same thing in terms of type. For example, if we say that we want type 2, which is basically a string.
How are you?
I
figured that you have a lot more pizza than you know what to do with.
We have people online as well.
Are they here?
Yes, they are.
Oh, no.
That's fine.
All right.
Come and join. We have another pizza heater here because that's too much pizza for just 2 of us. But as I was saying,
Quick
we can
question.
also filter,
I believe someone has. I believe someone has a question, Roberto.
The what, sorry?
Oh,
it's a question. I'm sorry. Yeah. Please interrupt me whenever.
I actually don't have a question right now. I might have a question later. Just want to know.
Okay.
Go ahead and do it.
He said he didn't have
I'm
one.
good right now. Yeah.
He may have one later. Okay, that's fine.
All right. We'll do it later then. So as you can see, we have these structural, let's say, operators, which are, for example, if a field exists or the type exists. So again, we can do it. Now, obviously, we could also do something like, let's see if number is type string. It will not give us that information because there's no such thing as a field number, which is a string. They are all fields. They're all integers in this case. Now, if you are wondering, well, this sounds like we have in front of us a JSON objects database, right? So we can just express things in JSON, and well, it's just JSON database. That's probably very complicated to handle because JSON only has 6 data types. It has null, it has binary. No, it doesn't have binary. So what's going on here? So you will also have integer, you can have number, string, and array and object. So those are the 6 different data types that a JSON allows. But in MongoDB, we don't use JSON. JSON is just with this JavaScript interpreter, which is our shell. We allow a lot more richer data types. We have int64 bits values, floating values, binary values, date types, all sorts of different data types, richer data types. And actually with this version here, 3.3, which will soon become 3.4, our official version, we will have decimal support. So you can define all sorts of different length in terms of floating point variations for a particular value. Now, this also allows us to express some queries like, all right, so what about the greater than let's say 6. Can we do that? Yes, we can. We just need to express $GT, and we'll find all documents that are greater than 6. As you can see from this data set, it's 789. Well, what about between 6 and 8, for example? Can we also do that? Obviously we can, which we define lower than equals, and we say 8. So then we reduce the scope. So all of this can be pretty extensive in terms of the number of operators that we have. I'm not going to go through all of them, but just to get you guys to understand that we have a bunch of them. So you can express any kind of rich query that you might think of. The other important thing, and since we are talking in a Linux group, is that there might be a lot of, I don't know, system administrators and DBAs out there, or people that are looking to move into that position. If you are knowledgeable about a little bit of MongoDB or database in general, just expressing queries with a small data set is easy, and it's not really relevant, because this will be very, very fast. What I really need to do is optimize queries from time to time. And for that, well, databases generally have an explain command, and we can explain exactly how MongoDB is gathering that information. So in this case, we're going to have a index filter set. That's the type of query that we are doing. And for that, we are going to be parsing a query, where we're going to express a number, which has to be lower than 8, and then the same field has to be greater than 6. And then we define a winning plan. The winning plan means how are we going to fetch all of that information. And in this case, since we are using number, and number has nothing than just a number on it, so it doesn't have an index to support it, we are going to do a collection scan. If you are familiar with full table scans or some other nomenclature for these long sets of fetch results out of a database, this tends to be the worst case scenario, where you need to go through all and each single document in your collection or table to just find all documents or results that you need. This only gives us a little bit of a statistic information, so it doesn't actually execute the query. If I want to do that, I need to do explain results. I can't remember exactly what I need to say here. Let me go find it. Execution stats. Sorry. Wrong day. Execution stats. Okay, so if I run my explain with the execution stats, I'm actually going to collect all statistics required to run this query. Again, the difference is that from execution stats, we get the exact number of returned objects. How much time it took? Less than 0 milliseconds, great. But it did examine 11 different documents to get that result. If we would have 1 million, we will need to go and examine all of those 1 million documents again. So that would be very, very, very bad. Another thing that we can do to optimize this is, or the thing that we should do to optimize this setup, would be to go to our people collection and create an index. And that's also totally possible in MongoDB. In this case, we're going to create an index on the field number ascending way. We can also do it descending if we've specified -1. So once we do that, the index is created. I can check which indexes I have in my collection by the command get indexes. It will give me the whole amount of indexes available for this particular collection. As you can see here, there's a primary key. As I mentioned before, it's just _ID. And that's always indexed. Definition of a primary key has to be unique, it has to be indexable. Also, I have a secondary index on the field number. So next time that I run the same execution explain, I'm going to have probably a different result. And in this case, I'm going to have an index scan. This is basically a set defining me that the stage that I'm using to fetch all of those results is actually supported by an index. And we can see, well, not in the execution time milliseconds estimate, that's 0 as well, but the number of returned documents, which is 2, and the number of filtered, let's see if I find them, examined keys is also 2, meaning that we needed only to find 2 keys in the index to return the result, which is the most optimum of all. The end result is exactly the same amount of documents that I examined. So for a database, this is gold. So what I want to get out of this, all of this talk about this particular section here is that in MongoDB, if you start seeing something going slow, make sure that that stuff is supported by an index. If it is, the chances that we have that will be greatly enhanced by in terms of performance and fetch speed. All right, so there's another. You have a question?
Yes, I do. If I see a query going slow, and you said make sure I have an index, could there be other issues with the query outside of an index, or is it mostly or is it index issue?
I couldn't quite hear that. Can you? Do you mind writing it down?
Sure.
And I can see
I can
it.
tell you what he said. He's like, is there something? He's like, is there anything else they need to look at outside of the index? So if it's moving slow, and it's not the index, is there something else to look at as well?
So, in general, the number one reason for things to go slow in MongoDB, especially on fetch, so in read, will be lack of indexes or inappropriate indexes. That can also happen. But in general, if things are going very, very slow, that will be the major reason. Now, there are other reasons that might affect your performance. Right now, we are dealing with a very small data set, and by default, everything will fit in memory. So I'm going to make sure that if you have enough memory to allocate for your system, it will use it as much as possible, or given the bounds that you might define for the usage of memory. Now, if you have a very large data set, like terabytes of data, and you only have, let's say, 10 gigabytes of RAM, obviously, every time you fetch for a document and you require that, if it's not in memory, you'll need to go and seek it from the disk. And I/O is probably the most expensive operation in your computational resources. So every time you need to go into your disks, and obviously depending on how fast those disks are, that will require more effort, more cost, and therefore more slowness. The other thing that can happen is MongoDB is a distributed system. So if you have a shard system which has multiple of nodes all spread across different data centers and so on, and if you are expressing a query like this one, but the number value here between 6 and 8 fetches so many documents that those documents are across different machines, and if your shard key, which is the rule by which we divide data across multiple machines, is not reflected by this field, you'll probably need to go fetch all of those documents, but across multiple machines. So that will mean that you're probably going to see a lot of lead time to get all the results, even though individually you have an index on that particular field. But since the data can be spread across multiple machines, you need to wait for the latest or the slowest machine of all to reply to complete the operation. In any case,
I think there's one.
In any case,
question.
Go on.
He's like, how many?
Does this answer your question?
Yeah, he had 2 other questions. He said, how many indexes can you have, and what is the index creation rules?
So the number of indexes that you can have per collection is 64. But I usually tend to say this in conferences, and probably Tamika can attest to this. If I see any time, or if I used to be a consultant for MongoDB, so I would go and help customers to work their issues with MongoDB out, the first thing I would ask them, before looking into their schema or their documents or whatever, I would ask them 2 things. how many collections do you have, and how many indexes do you have. I'll probably try to break your legs if you have something close to 64 indexes per collection. I'm not a very tall person. I can guarantee I'm not that physically enabled at all. I'm not a menacing person, but I do have a baseball bat now since I moved to the US, so I am totally able to do that. So the limit is hard-coded to 64. The maximum that I see fitted to a for supporting a single collection shouldn't be more than 10, 11, 12. I've seen cases where people had reason and we thought had 32 indexes in a collection. Every time we add up an index, we delay the write speed, because every time the index itself will need to be updated every time we do a write. So every time we insert a new document, we need to update every single index that is affected by that document. Every time we update something, every time we delete something, everything will be reflected times the number of indexes that you have. So you might be accelerating your read speeds for very, very random queries, but you're also going to be allocating more space. And with that, we're also going to be consuming more RAM. Why is that? Well, indexes as data, they are data structures. And data structures, to be traversed or to be maintained or to be analyzed, they need to occupy RAM, otherwise we can't look into them. So if you have a lot of indexes, if those indexes occupy space, they will be occupying space that could be occupied by documents. So therefore, you're going to have to contention not only in terms of the number of write operations that you'll need to do in parallel, but also the amount of RAM necessary to maintain those indexes so they can be traversed. So you need to measure all of these different things when you are dealing with that. But to the short answer, this is a long answer, the short answer to your first question is 64. With all this talk, I forgot about what was the second question.
Second one,
you know what?
yeah, the second one was are there, I guess he was asking, are there index creation rules?
Rules. Oh yeah, so if you have 90% of your queries being around 3 to 4 fields, those 3 or 4 fields definitely need to be indexed. If you have very recurrent queries that are very important in terms of SLAs and they are not supported by an index, they should definitely be now. Now, it will depend a lot on your usage pattern and how you fetch information. Let's say, for example, that we have a social network, just to say a use case, and probably what we get is the individuals, when they connect, they will probably have, like, I don't know, a news feed or something like that, and they will need to query a collection for that news feed. The first thing that you need to access would be, what are my latest news feeds entries there? So that would be a timestamp. That timestamp needs to be sorted invertly to get the the latest news there. But you probably also want to index on the submitter of that news, where does it come from, and if it's directed to you or not. So you can make preferences there. So all of those fields should be on an index. And the fact that we have this particular index, all indexes do not need to just have one field. They can also have other fields. Let's say, for example, that we want to look on users, ascending, and their title, descending. That is also totally possible. That's what we call a compound index. So let's say that for this people collection, if we would be looking into user, let's say 80% of the time, 80% of the time we'll be looking into some query that would use that field. Well, 80% of the time, this would be supported by an index. Because we also make sure if we use user in all those queries, if we put it as the left-hand side element of the query creation, the index creation, that index will be used. I can show you that by expressing a query, not particularly this one. Let's say, for example, that I want to express a query where user is actually starting with T, And this is a regular expression that I can define. And dot star, for example, if I execute this, I'll see that I'm actually using that particular index. Okay? Although the index was created with more than one field, title, I will be using that index. Obviously, again, if I use sort, find all the users that start with T, and also sort by title, we're also going to be using the index not only for the fetch, but also for the sort. As you can see here with this stage, which is sort key generator, you will actually use an index to do exactly that. So there's a bunch of different variations that we might be using indexes for, and there will be very different use cases where an index might be very efficient and another index might not be that efficient. So the rules in itself is, what is your users doing, or which queries are you submitting to MongoDB? How do you want them to be sorted, limited, fetching, if you have regular expressions on it, if you are just doing direct matches, if you are doing, for example, range sorts or range queries, all of that will count on finding the good or more optimal indexes. So that is actually something that we cover on our university courses on M101. Okay?
Okay.
So I'm good. This is the basic setup to set up MongoDB and to look into how it's installed. It's very quickly. Let's do that. I'm gonna kill this process. I like to kill processes. I don't know if this makes me a mass murderer of process at all, but I really like to kill it. So I can start a service because I've installed this through Yum. Actually, to install this in Ubuntu, for example, this is apt-get install, and it's generally is Mongo Enterprise for this particular version. If you have all the repos, and I can show you a particular repo that I've set up, which is on etc repos apt whatever, how's it called? How do we generally do this? Let me see.
What are you trying to do?
The repositories for apt.
I know for Yum it's Yum repo. Let me look it up. I don't.
Oh, you were a Red Hat girl.
Hey man.
No, that's fine. It's okay. I mean, people make choices, bad or good, doesn't really matter. Oh, there he is. So it's CD cats in etc apt
Sources list.
and sources lists, or directly apt dconf sources lists. There you go. And here we installed. Let me grab MongoDB. Oops. Oh, we didn't put it here. Let's see if I put it somewhere else. It's not really important. I would just like to show you guys how I did it. Let me show you what I did from the Vagrant file. Here it is. So the only thing that you need to do is, for example, here you go, sources list D, and create a MongoDB Enterprises list. And there we will find this particular message here that tells us that we have a repository that you can use to install MongoDB. Actually, I'm going to just send you guys this with all the material that we are covering today and with the presentation itself. All right, so we are fast approaching our time for my hard stop, so let me try to see if I can cover the last part of the material. To get our first app started, we can go and just follow some tutorials that we have online. Obviously, we will not be building applications from the shell. We'll be building applications using a driver or some language. We need to first know how to connect. This is as simple as defining a host and calling that function called Mongo client. This will be our client instance. This will be the one responsible for managing all of our operations in and out from MongoDB. We also can define a server host in this case if we have a, for example, using a MongoDB URI instead of just a host. That's also possible. This is all the Java typical examples, but the same thing will apply for Python, for Ruby, for PHP if you do that kind of thing. I don't judge you, it's just PHP. But you can also connect to replica sets. We just need to define a seed list, give it back. We can list all our databases and collections. We can set up security, like defining username and passwords, for example. We can write to a database, which is very convenient. If you want to insert a document, MongoDB driver will initiate an object for you. So another difference between MongoDB and relational systems is, for example, we don't need to know the insert statement in SQL. We just use an object. Or we just map an object that we are dealing with a object mapper, and we're done. You don't need to care too much about it. There's a bunch of other examples on inserting, on updating from a Java object, from all sorts of different queries, using the set operator or not, how to remove a POJO, how to remove all. Well, there's a bunch of different operations like bulk writes and so on. But I need to leave it right now. I have really a hard stop at 7:50. So any questions that you guys have, please send it to Tamika. I'll make sure I'll answer them. The content will be available, so you guys can just go through my beautiful slides and tell me back that I should fix my spelling mistakes, which is all good. All right? Pleasure having you guys here. I'm sorry you couldn't taste our lovely pizza. Next time will be.
There's no problem. Thank you,
Right,
Norberto.
Tamika?
Yeah, thank you.
Thank
you
you,
everybody
guys.
for coming out. Hey, Norberto, are you gonna put them in a GitHub, or are you gonna put them?
I'll send it to you. You distribute it as you like.
Okay, appreciate you.
Thank you. Bye.
Bye, everybody.
Thank you to me.
You're welcome.